All right, guys, we're going to talk about this temperature quotient, Q10, today. This is one of the equations that you'll see on the equation sheet that's given to you on the AP exam, Q10, this equation right here. So we're going to use that right now. And then there'll be a follow-up video to this on how to use it in the lab. So it's a quotient, it's a factor by which the rate of reaction increases for every 10-degree rise in temperature. So we're going to talk about goldfish in this case. So R, the rate here, could be a number of things. Flow of ions through a membrane, so this could be in the kidney, chemical reaction rate, or a respiration rate, which is what we're going to talk about with the goldfish. So we're looking at the respiration rates of goldfish, which is a cold-blooded animal. So what could actually influence that respiration rate? So that could be a demand for O2, which that could be from any kind of activity, swimming around a lot, or it could be their metabolism. They just ate. They need more oxygen for the metabolism. Temperature can influence this since they're cold-blooded. The warmer they are, the more demand their cells have for oxygen. How much O2 is actually in the water can influence how much they're breathing, what their respiration rate is. So when the temperature drops, ectotherms have a lower demand for O2, and we can actually measure that. So we can look at how many times they're gulping water in to get water across their gills for oxygen uptake. So we can calculate Q10 based on how many times they're gulping. And so this is what it would look like. So here's the equation that was on that equation sheet, and here's what all the variables mean. So we've got K2, that's the metabolic rate at T2, which is going to be the warmer temperature. The metabolic rate at T1 is K1, and this is the cooler temperature. So metabolic rate is going to be the fish gulps at warm temperature and cool temperature. So of course T2 and T1 are those temperatures. So here's an example on how to work one of these out. So here's pretty much what you would be doing in the lab. Calculate Q10 for a fish that gulped water this many times at this temperature, and then we cool that temperature down and they gulped fewer times. So we're just going to plug all those values in here and solve for it. So our metabolic rate at the warmer temperature is 62. Our metabolic rate at the cooler temperature is 20. So they're gulping way fewer times. The warmer temperature was 23 degrees, and the cooler temperature was 10 degrees. Okay, so we're just going to fill those in. So 62 over 20 to the power of 10 over 23 minus 10. Okay, so here's what that looks like. So if we do 62 divided by 20, we're at 3.1, and 10 divided by 23 minus 10 is 13, so 10 divided by 13. So we're at the power of 0.769, 0.769. So we have 3.1 to the power of 0.769. So there's our Q10, 2.39 if we rounded, 2.39. So what that actually means is that for every 10-degree rise in temperature, the goldfish, their metabolic rate increases by more than double. It's 2.3 times higher than it was at 10 degrees lower of a temperature.